Every year, millions of tons of raw sugarcane begin their journey from field to table.
It all starts with the harvest, where each stalk is carefully selected for maximum sugar content. Modern mechanical harvesters can process up to 60 tons of sugarcane per hour. Each bundle must be transported quickly to preserve the sugar content before it begins to deteriorate. Transportation is time-critical. Within 24 hours, the cane must reach the processing facility. The journey from field to factory is the first race against time in sugar production. Welcome to the sugar mill, where raw cane becomes refined sweetness.
Each truck is weighed and analyzed for sugar content before unloading begins.
Quality testing determines the payment farmers receive and the processing parameters needed. Unloading must happen rapidly. The mill processes cane 24 hours a day during harvest season. The first mechanical stage removes leaves, dirt, and debris from the harvested cane. Powerful water jets clean each stalk, removing field contaminants before processing. Magnetic separators and screens protect the expensive crushing equipment from damage. Clean cane moves to the preparation area, where the real transformation begins. This is where millions of stalks meet their first mechanical transformation. Rotating knives, spinning at high speed, shred the cane into small pieces for maximum juice extraction.
Shredding ruptures the cell walls, making the sugar-rich juice easier to extract.
The shredded cane now enters a series of crushing mills that extract every drop of juice. Each mill applies thousands of pounds of pressure, squeezing out the sweet liquid trapped inside. The extracted juice contains about 15% sugar, along with water, fiber particles, and impurities. The cane passes through multiple mills, each one extracting more juice than the last.
Quality control checks juice purity and sugar concentration at every stage. These tanks can hold hundreds of thousands of gallons of raw juice awaiting processing.
The leftover fiber, called bagasse, becomes fuel for the factory's boilers. Nothing is wasted. Bagasse provides enough energy to power the entire sugar mill. This renewable fuel source makes sugar production remarkably energy efficient. The bagasse burns at high temperatures, generating steam for processing and electricity for operations. The extracted juice begins its journey through purification, where impurities will be removed. At this stage, the juice is dark, cloudy, and far from the pure sweetness we recognize. Purification is critical. Removing impurities affects both quality and shelf life of the final sugar.
Lime is added to the juice to neutralize acids and bind impurities together.
Massive agitators ensure complete mixing of lime throughout thousands of gallons of juice. The mixture is heated to 100 degrees Celsius, causing proteins and impurities to coagulate. As heat activates the lime, impurities rise to the surface, forming a thick layer of scum. Gravity does the rest. Clean juice settles to the bottom, while impurities float upward. Automated skimmers continuously remove the impurity layer from the surface.
The clarified juice is now significantly cleaner, though still far from pure white sugar.
The juice passes through multiple filtration stages to remove remaining solid particles. Fine filter cloths trap microscopic particles while allowing the sugar-rich juice to flow through. The filtered juice collects in settling tanks where any remaining particles have time to drop out.
Each filtration pass brings the juice closer to the purity required for crystallization.
The difference is remarkable, from murky green-brown to clear golden amber. The clarified juice typically contains 12 to 15% sugar by weight, perfect for evaporation.
Precise pH monitoring ensures optimal conditions for the chemical processes ahead.
This clarified juice represents only about 15% of the original cane weight.
The removed impurities, called filter cake, are rich in nutrients and become agricultural fertilizer.
Like bagasse, filter cake demonstrates the sugar industry's commitment to zero waste. The evaporation system is the heart of the sugar mill, where dilute juice becomes thick syrup.
Multiple evaporator vessels work in series, each one removing water at lower temperatures.
As water evaporates, the sugar concentration rises from 15% to over 65%.
The evaporated water is captured, purified, and reused throughout the factory. After 4 to 5 evaporation stages, the thin juice has become thick, concentrated syrup.
The syrup is now 65% sugar, thick as honey, and ready for crystallization.
Precise temperature and pressure control prevents caramelization and maintains sugar quality.
The system operates under vacuum, allowing evaporation at lower temperatures to protect the sugar.
The concentrated syrup is held at precise temperatures while awaiting crystallization.
Quality control ensures the syrup has exactly the right sugar concentration for crystal formation.
The syrup's thickness is critical. Too thin and crystals won't form properly.
The syrup is now ready for the most critical stage, crystallization.
Temperature must be maintained precisely. Even small fluctuations affect crystal quality.
At this stage, the syrup contains virtually no water. It's a supersaturated sugar solution.
The energy efficiency of this system reduces the factory's fuel consumption by over 70%.
Automated systems monitor every parameter, but experienced operators provide critical oversight.
The syrup's stickiness requires constant cleaning of equipment to maintain efficiency.
This is where the factory earns its name. The sugar mill transforms liquid into crystal.
Now the syrup enters crystallization, where sugar finally takes solid form.
These vacuum pans are where the magic happens, turning syrup into sugar crystals. The syrup is heated under vacuum, causing it to boil at lower temperatures. Tiny seed crystals are added. These will grow into the sugar crystals we recognize.
As water evaporates, sugar molecules attach to the seed crystals, growing them larger.
Over several hours, microscopic seeds grow into crystals nearly 1 millimeter in size.
Operators constantly monitor crystal size and syrup concentration throughout the process.
Perfect crystal formation requires precise control of temperature, pressure, and evaporation rate. Multiple pans operate in parallel, producing hundreds of tons of sugar crystals daily.
The crystallization process takes 3 to 4 hours of careful temperature and vacuum management. When crystallization is complete, the massicouite contains about 55% solid sugar crystals.
The finished massicouite is discharged by gravity into centrifuges for separation. The mixture must be kept hot during transfer to prevent premature solidification.
Each crystal is still coated in thick syrup. The next step is separation.
Industrial centrifuges spin at high speed to separate crystals from syrup.
The massicouite is loaded into perforated spinning baskets lined with fine mesh screens.
Centrifugal force pushes the liquid syrup through the screens, leaving crystals behind. The centrifuge spins at over 1,000 RPM, generating forces strong enough to separate the materials.
The separated syrup, called molasses, still contains sugar and undergoes further processing.
High-pressure steam washes the crystals, removing any remaining syrup coating.
After separation and washing, what remains is raw sugar, golden white crystals ready for drying. The raw sugar still contains about 2% moisture and needs drying before storage.
Each crystal is a perfect geometric form, nature's architecture at microscopic scale.
The raw sugar moves through rotary dryers, where hot air removes excess moisture.
Hot air at carefully controlled temperature ensures moisture removal without melting crystals.
After drying, the sugar's moisture content drops below 0.5%, essential for storage stability.
Vibrating screens sort the sugar into different grades based on crystal size.
Uniform crystal size is important for consistent dissolving properties and appearance.
From fine baker's sugar to coarse decorating sugar, all from the same raw material. Massive silos can store thousands of tons of finished sugar awaiting packaging.
From bulk storage, sugar flows, to automated packaging lines operating 24/7. Packaging happens at remarkable speed, up to 40 bags per minute per line.
Automated systems ensure consistent weights and hermetic sealing for maximum freshness.
Quality control checks every aspect: weight, seal integrity, and label accuracy.
Proper sealing prevents moisture absorption that would cause clumping and deterioration. Robotic palletizers stack bags with perfect precision for efficient shipping.
Pallets move to temperature-controlled warehouses awaiting distribution worldwide.
This warehouse holds the equivalent of millions of sugarcane stalks processed into pure sweetness.
From raw green stalks to pure white crystals, the transformation is complete.
These trucks will deliver sugar to bakeries, manufacturers, and stores across the region. The journey from field to table involves dozens of processes and hundreds of workers. For even purer white sugar, raw sugar undergoes additional refining processes. Raw sugar is redissolved to remove the remaining color compounds and impurities.
Activated carbon filters absorb color molecules, producing a perfectly clear solution. The difference in purity is remarkable, from amber to water clear.
The purified solution undergoes crystallization again, producing brilliant white sugar crystals. The refined crystals are separated, washed, and dried just like raw sugar.
Refined white sugar is 99.9% pure sucrose, one of the purest food products available.
This pure white sugar is what consumers find on grocery shelves worldwide.
All these products begin with the same raw material, the humble sugarcane stalk.
From millions of raw sugarcane stalks to the sweetness in your coffee, this is the full factory process.
This factory processes over 10,000 tons of sugarcane daily during harvest season.
Each crystal represents nature's precision combined with industrial engineering.
The journey takes just 48 hours from field to finished product.
Ultimately, sugar exists to dissolve, to disappear, while leaving sweetness behind.
This is how millions of raw sugarcane stalks become the sugar that sweetens the world.